Sure, someone always wants to be the hero and solve everything himself. The doctor just does not realize how big this case really is. The slasher has left a trail of dead bodies to 5 states.
Agent 008 left, closing the door quietly as he walked down the hall. He could hear the doctor's voice describing the victim's gruesome appearance into the tape recorder fade away.
The hallway from the coroner's office to the elevator is long and dark, but this was the only way to Dr. Dedman's office. Does this frighten most people? Well, it doesn't seem to bother old Ajax Barak, so there he is mopping the floor.
Agent 008 stopped briefly to use the restroom and bumped into one of the deputy's coroners, who asked,
Dedman still at it?
Sure is, Dr. Quincy. He's totally obsessed. He's certain there is a clue.
as usual, when leaving the courthouse, 008 had to sign out.
How's it going down there, Agent 008?
Sergeant Faust asked. Faust spent most of his shifts monitoring the front door, forcing all visitors to sign in while he recorded the time next to the signature. Agent 008 wondered if Faust longed for a more exciting aspect of law enforcement.
If I were doing Faust's job, I would get a little stir crazy sitting behind a desk most of the day. Why would someone become a cop to do this? Oh, sorry. Dr. Dedman is convinced he will find something soon. We'll see. It's already 10 minutes before 2 o'clock. Will I make it back to headquarters before the chief leaves?
Well, good luck.
It was later in the afternoon when Agent 008 returned to the courthouse, sighing deeply.
Would the secret guest please sign in?
Sign in again. Annoying. 5:05 p.m. Wow, I hadn't planned to be gone so long.
For a moment, Agent 008 saw a positive point to having anyone who came in or out of the courthouse sign in. He knew by quickly scanning the list that Dr. Dedman had not left. In fact, the old guy must have still been working on the case. As he approached the coroner's office, he had a strange feeling that something was wrong. He could not hear or see Dr. Dedman. When he opened the door, the sight inside stopped him in his tracks. Evidently, Dr. Dedman was now the newest victim of the slasher. But wait, the other body, the one that doctor had been working on, was gone. Immediately, the security desk with its annoying sign-in sheet came to mind. Yes, there were lots of names on that list, but if he could determine the time of Dr. Dedman's death, he might be able to scan the roster to find the murderer. Quickly, he grabbed the thermometer to measure the doctor's body temperature. He turned around and hit the security buzzer. The bells were deafening. He knew that the building would be sealed off instantly and security would be there within seconds.
Faust.
How could this happen? I spoke to the doctor less than an hour ago.
As the security officers crowded in the room, Agent 008 explained what he knew, which was almost nothing. He had stopped long enough to check the doctor's body temperature.
27 degrees Celsius. That's 10 degrees Celsius below normal.
Then 008 remembered the tape recorder. Dr. Dedman had been taping his observation. That was standard procedure. They began looking everywhere. The slasher must have realized that the doctor had been taping and taken the tape recorder as well. Sometime later.
The thermometer is still in Dr. Dedman's side. Exactly an hour has passed during the search, and the thermometer clearly reads 24 degrees Celsius. Now I can determine the time of death.
Okay, so what's happening here, guys? What just happened? Who can summarize this little scenario that everybody so eloquently read?
Dr. Dedman died.
Dr. Dedman died, and he's like the autopsy dude, right? So he was performing an autopsy on a body, and the Agent 008 came to see him to try and find out who the slasher is. We're trying to figure out who the slasher is, who the killer is. But while Dr. Dedman was investigating, doing the autopsy, he became a, what's the word? He got killed. He became a victim. That's the word. He became a victim and he was killed and we're trying to figure out who killed him. Who is the slasher? So to do that, we have 2 points here, basically. He took 2 measurements. Agent 008 took 2 measurements, and that's Dr. Dedman's body temperature. So the first measurement he took, Dr. Dedman's body was 27 degrees Celsius. And did it say in here what normal temperature, body temperature is?
I think it's 37 based on context clues.
Right.
Yes, that was 10 degrees below normal.
Yep. It's 10 degrees below normal. So yes, it is 37 degrees Celsius is normal body temperature. There you go. So 10 degrees below normal. So that was his first reading. So that means he had died some time ago. But if we can figure out the rate of cooling, right? How quickly is the body cooling? Then we can go backwards and figure out when he was killed. Yes. So the second measurement we took is at what time? An hour later, right? So the first measurement when he found the body, it was 27 degrees Celsius. An hour later, it was 24. It dropped 3 degrees in 1 hour. Okay. Now, when something cools, and I forgot to talk about number 37 on your homework. So this is important, guys. When something cools, this is basically the lesson for today. So when something cools, like a cup of coffee or whatever, let's say we have a cup of coffee, and let's say, I don't know how many degrees is a cup of coffee. It's really hot. Let's just say it's, I don't know, like, let's say it's 40 degrees Celsius. Okay. And then it's going to cool, but there's going to be an asymptote here, right? What temperature is it never going to pass? Never going to go below?
Room temperature.
Room temperature. Okay. That was number 37 on your homework. It can never go below room temperature. Why can't it go below room temperature?
It would need something colder than the room to be able to go below.
Right, exactly. So, yeah, it would need something colder in the room. Okay. So it's going to go the same temperature that whatever the room temperature is, right? So the environment that it's in. So let's say room temperature, I don't know, I'm just making this up, is 10 degrees Celsius. So the cup will never go, so this coffee will never go below 10 degrees. So we have created an asymptote. Okay, so your equation is going to look something like this. And we do want to write this down on your notes. Y equals, and we want to actually add this to our parent graph toolkit as well. Y equals A times B to the X. This is our normal exponential decay, right? This is a decay problem because the problem is going down. And usually our B is between 0 and 1 if we're decaying. So it's like, 0.5 or 0.75, or, it's a decimal between 0 and 1 because it's cooling, it's going down. But since we have an asymptote that we need to create, we're going to have minus H for the exponent and a plus K. The K is your asymptote. Okay. That is your asymptote. So let's write, this is the asymptote. The H is if you shift it to the left or the right, because X is always going to be your time, right? There's always going to be some amount of time here. Time is our X. And so if you do X minus H, H is going to be hours, the number of hours or seconds or minutes, whatever time before or after the time 0. Before or after T equals 0, or X equal, let's put X equals 0. When the time equals 0, your beginning time or your end time. So it's going to tell you a time. So T equals 0 is when he finds the body at 27 degrees. Okay. And then 1 hour later, T equals 1, we now have the body's at 24 degrees, right? So T equals 0, it's at 27 degrees. So we have 2 points on this graph. We know this starts at 0.27. I'll change this. The graph starts at 0.27. And hold on a second. Okay, so we have the first body temperature is at 27 right here. So this is 27 degrees. And then an hour later, it is at 24 degrees. I should draw it like a little higher. It's more like this for his graph. It's at 24 degrees. And then what is the room temperature? Did it tell us the room temperature? I'm pretty sure it told us the room temperature somewhere. Somebody notice that? I believe it was 17 degrees Celsius, right? I believe temperature was 17 degrees Celsius. So our equation is going to look like this, right? This is the main equation here. This is today's lesson. When you have a cooling temperature, there's a certain amount it can't go below. Whatever that amount is, that's your K value that you have to add to your equation. Okay, so if it's 17 degrees, then our equation is going to be like y equals sum a times b to the x minus h. And if it's 17 degrees, we're going to put plus 17. Okay, and your a value is going to be, your a value here is, even though it starts at 27, it's not going to be 27 here. It's going to be something like 10, because you're going to need to add 10 plus 17 to get the 27. You see what I'm saying? So, and we have to figure out the a value. Okay, so that's what we're going to do next. So having this information, hopefully you wrote this down, especially this part right here. If you haven't,
wait, can you keep it up for a little bit longer? I'm so copying.
I can keep it up for a little longer. Okay, so especially this part here, the graph would be good too. So I'm going to give you a second. If you need to take a screenshot and get it down later. But I need to show you how to solve this problem next.
Sorry, what is the variable?
I'm good.
Again?
The variable is x.
Variable t, like t equals 1 or t equals 0.
It's the same thing as x. Usually we use t for time. So instead of t, we'll use x, but x is time, right? It's your x axis right here.
Oh, okay.
So, technically I can make it the time minus h. I can make this the time minus h, but we just use x because we like to use x and y. So x is the time, usually in hours. And then h is how much before or after. And we'll do an example of this on the worksheet that I gave you. I'm going to do number 1 with you on the worksheet, and I'm part of number 2. Okay, so we're going to have a couple more examples besides this one. All right, guys, we good? If you're not good, take a screenshot. I got to move on to the next part. Okay, the next part is off of, so I found somebody who made a great presentation that I'm borrowing here. And here it is. I need to go back. Okay, this is confidential. This is Operation Dr. Dedman, right? Operation Dedman, who's the doctor's name. Information. We know the room temperature is 17 degrees Celsius. We know Dr. Dedman's body was 27 degrees Celsius, and you don't have to write this down because we already discussed this. If you want to take little notes, you can. You don't have to write all this though. The body temperature drops 3 degrees. I wouldn't say every hour, but it dropped 3 degrees from the hour that he put the thermometer in, because it's not a constant rate that it's dropping. So every hour is not correct. It dropped 3 degrees in the hour that he measured it. The average body temperature is 37 degrees. So we established that. So let's go to the next part. So this is our original equation, right? A times b to the x plus K is what I gave you. They're using C, but you know, we're using H and K. So this is a K, right? So you already have that written down, so you're good. Okay, here's our first step to solve for A. This is what we need to write down for this problem. And this is problem 2-42. So if you haven't, I'm sorry, not 2, we're on chapter 7-42, right? So you have that on your paper. So we're gonna solve for A. This is what we need to write down right here. 27, because the first reading that he took was, we had 0.27 and 1.24, right? So we need to plug this in for X and Y. So our equation was Y equals A times B to the X plus K. Okay, so our X is 0. So we're going to plug in 0 here. We're going to plug in 27 here. So that's the equation. 27 equals A times B to the 0 plus 17, because that's room temperature, right? That's our, hey, it's never going to go below 17. It's going to go like this, and cool, 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 and never go below 17 degrees. Okay, when we solve this, B to the 0, you know, anything to the 0 power is 1. So that's where this 1 comes from. This B to the 0 part is 1. So we have A times 1 plus 17 equals 27. So that's the next step. Okay. So basically we have 27 equals A plus 17. Then we just need to subtract 17 from both sides. So what do we get for A? A is 10, right? So we get A is 10. So now we can plug that back into our equation. We can plug 10 in here. And I told you earlier on that I knew it was going to be 10, because 10 plus 17, 10 plus 17 equals what we got, 27. Okay, so we good with that? Ready to go on to the next slide? Okay, so now that we know A is 10, we can plug it back into the equation. We can plug it back into our Y equals A times B to the X plus K, right? So we found that this is 10. So we're basically plugging this, and now we're going to plug in the other point that we have, which is 124, right? We already used the 0.27. Now I need to use the 124. So the 24 goes here, equals 10, the A value that we found, times B to the first power, because that's what our X is, right? Plus 17. So now when I simplify this, when I subtract 17 from both sides, I subtract 17 from here. What do I get? 17 is, 24 minus 17 is 7. So 7 equals 10 times B to the first power, right? So to solve for B, 7 equals 10 times B, basically. I'm going to divide by 10. Divide by 10. So B equals 7/10 or 0.7. Remember we said B needs to be between 0 and 1 to have a decay problem, for this problem to be cooling, right? With our asymptote, always draw the asymptote in, super important. So we got a number between 0 and 1. 0.7 is between 0 and 1. So that's good, right? How fast is it cooling? How much is it decreasing? What's the percent decrease every hour, guys? How much is it decreasing every hour? If it's retaining 70% of the temperature every hour, right? We're taking 70% of the previous
30%.
So say again?
30.
Exactly, 30% decrease, right? So that means it's decreasing 30% every hour. How do I get that? I just take 100 minus 70, I get 30, right? Because this is 70, this is 70% right here. So 100 minus that percent, because you move the decimal point over 1-2 places to get your percent. Subtract it from 100, so it's a 30% decrease. Okay, this is all review from Algebra 1, because I'm teaching this to my Algebra 1 class right now. So I just wanted to review that because it's been a couple of years since you had Algebra 1, although we did this at the beginning of the year too. So I got to erase this, go to the next. So we found A and B, right? That's the main thing. We had to find A and B. First we found A, now we found B. So now we can plug it into our equation. Calls it the mother equation. I would call it a parent equation, right? Y, sorry, our parent equation is Y equals 10 times 0.7 to the X plus 17. Okay, so that is our parent equation. Okay, and if we had to do a graph, of course, you know.
How do we know there's no value for H?
Right, there's no value. It's not moving left or right because we didn't do 2 hours before. So our X equals 0 is when he found the body at 27 degrees. Okay, we are going to do an example where we have an H. Okay. And then we had 124. And then 17, let's say, is right here. And then we have our asymptote. And so 124. So the temperature is going like this. We want to find when he was killed, which is somewhere over here, right? At either -1 hour before, -2 hours before, -3 hours before, or somewhere in between there. He was killed whenever his body temperature was 37 degrees. That's what we need to find, right? So that's our next step, right? What should we do with the equation to find when he was killed? Plug in 37 for the temperature times 10 times 0.7 to the X power plus 17 and solve this for X. And because X is an exponent, we're going to have to use logs to solve this. That is the application of logs. When you have X as your exponent, you have to use a log to solve this. Okay, so how do we solve this? What do we do first? This is like your Wednesday work. This is exactly what you did for the assignment that I assigned on Wednesday. See, it's not just busy work and stuff. It's like stuff that you have to do on the test and quiz that's coming up. 37 minus 17 is 20 equals 10 times 0.7 to the X. Next step, what do we do next?
10 times 0.7.
So, nope. I'm glad you said that because you don't want to do that. You don't want to do that because you do exponents first, right? So you should do the 0.7 to the X and then you multiply by 10. So never multiply these first. So we need to get rid of this 10, right? So we need to divide by 10. 20 divided by 10, that's easy enough. That's 2 equals, and then we got rid of the 10, 0.7 to the X power. How do I get rid of this X, guys?
How do you get rid of it? Probably square root.
I'm glad you said that too, Mateo, because you can only square root if it's squared. Let's say it was 0.7 squared, or it was X squared. That's when you square root, right? But is this a squared? No, this value is
No, I was just saying that. I was saying that for education purposes.
Okay, thank you. I appreciate you for educating us. Okay, we can't take the square root because this is not a square. You can only do that if it's something squared, right? So this is what I'm talking about. We have to use logs. So let's change it to log form. You can either take the log of base 0.7 or let's change it to log form. And I hadn't thought about doing this before, but it just occurred to me to do it this way. If I change this to log form, what am I going to have? Log of log base 0.7 is equal to, I'm sorry, not equal to, I need a log base 7 of 2 is equal to X. Is that how you change from exponential form to log form? This will give me X. Okay, what do I have to do for here? You can't put this in your calculator like this. So what do I have to do with this? Because this is not log base 10. You have to use the change of what, guys?
Base.
Change of base formula. You have to change the base because right now it's base 0.7 and your calculator can't do 0.7. So if you use the change of base, it goes the log of the big number over the log of the bottom number. So log of 2 over log of 0.7. These are log base 10. So now you can put this in your calculator. Please use your calculator to put this value in there for you, okay? I hope you guys have been using your log button. Do you even know where your log button is on your calculator? Put this in your calculator. You have to do your calculator puts parentheses, and so you have to put it in parentheses, or I just press equals after log 2, and then I do divided by log of 0.7 equals. So I do 2 equals. What do you get when you do that? I got a negative number. Is that okay to get a negative number? And what does that mean? What does x equals negative 1.94 mean? Are you guys there? It means he was killed. Say again?
Oh, sorry, I was going to say what you were about to say, which means he was killed almost 2 hours before.
Exactly. He was killed almost 2 hours before, a little before 2 hours. So 1.94. Okay, you can't say 1.94 hours. We need to figure how much this is in minutes. So how do I figure how much this is in minutes? Just multiply by 60. So just put times 60 in your calculator. And I get negative 116.6 minutes. Okay, so if I say how many hours or a minute, if I divide this by, well, 2 hours, almost 2 hours before, I was going to say divide it by, and you'll get almost 2 hours before. So if when did he find the body? What time did it say he found the body? I'm going to fast forward here. I'm going to go to the answer. I have to erase all this, so I'm going to do that. Next. Okay, third step, find the time of death. So we found negative 1.94, that's 116.6 minutes. And then go next, how long is that before? Let's see. So it must have been 5:11 when he came in the room, right? Or 5 o'clock-ish. So 2 hours before that is around 3:11 p.m. Okay, so he came in the room about 5. Oh, he signed in the log, right? So you're supposed to look at the log, and I didn't want to reveal the killer yet, but you can see who the killer is. And we need to look at the log to figure out who the killer is. And I attached that it's in your book, but it's also in the classwork. Where is the classwork for today? Right here. So the coroner's list, coroner's sign-in list. Okay, so is anybody in the room at 3:11? Look at the list here. Brock goes in at 2:20, comes out 2:43, so he's not in there. Pierce Bronson goes in at 3:48, which is after 3:11. These guys all go in after 4 o'clock, so it's not them. And let's see if anybody in here is in there. He left at 2:47. He left at 2:45. He left at 2:48. He is after 3:11, but he came after 3:11. So is anybody on the list in there at 3:11?
No.
No.
No, so it can't be anybody who came in and out of the building. So it's who? It's
Dr.
someone-
Dedman.
Dr. Dedman was the victim. So he did, we are assuming
Suicide.
he didn't commit suicide. It was somebody who was already in the building, which was
Lost.
Dr. Faust. He was like the other coroner dude. Remember, somebody was Dr. Faust in our play, and he was like doing other autopsies. And Agent 008 came in and said, "Hey, is he still at it?" He said, "Yeah, he's still in there." And it was Faust, because he never had to sign in because he was already in the building. Okay. He's the autopsy guy, right? He's not the security guy, because there was a security guy too that made everybody sign in. He was either the sign-in dude or he was the other autopsy dude. I forget which one, but it's Faust. So Faust is the killer. So you can write that down on your paper. Okay, so that's number 42. Little fun activity there. For the other homework, I'm going to do one of the problems with you. So you can turn in your work for this classwork here. Oh, I meant to do this thing here. I don't know if you guys did it, but I meant to put it up at the beginning of class. It's just a fun like emoji thing that you could make. You can do it later if you want. You pick a slide and then make an emoji of how you're feeling today. Like these are the things. If you're enraged, annoyed, anxious, or afraid, hopefully nobody's in the red. If you're inspired, excited, surprised, happy, you can make a regular yellow emoji. If you're disappointed, bored, down, or depressed, you can make a blue emoji. If you're content, serene, pleased, or mellow, you can make a green emoji. You just pick one of these slides. You can change the color by clicking on this and then clicking on the fill bucket. Let's say I'm green today, so I'm going to change it to green. You can drag these over and make a face and blah, blah, blah. So you can be creative. Put your name on the slide. Like I'll put Mrs. Wakefield here. Mrs. Wakefield is happy. It is Friday, and Mrs. Wakefield can't type on this computer. Mrs. Wakefield is happy it's Friday. And you can change the background. You can go to the background and add an image, choose an image. You can even choose an image from the web if you want to. Mountains, I like mountains. Mountains. So I'll pick that one and then insert it. And that should be my background. There we go. And, play with it, have fun. That took me all of 1 or 2 minutes. So if you want to click on that and do one of those, you can. That's cool. And but the other thing that I wanted to do was your homework. So this homework is several, and I have it in a better, easier to see format right here. So this is your homework. Okay, and here's so I wanted to do some of them because we didn't do an example that had an H in it. So when do we use this formula, guys? When you have something that's cooling, right? Like the rate of cooling of pudding is proportional to the difference between the pudding's temperature and the room temperature. Electric current is proportional to the difference in voltage between 2 points in a circuit. So we could use this for electric current. If you guys, any of you go on to take physics, you could take electrical physics. And if you're going to be an electrician, you definitely need to take a lot of electrical courses. So this would be an application of that. And you actually have to do a lot of math too. Diffusion of chemical across a membrane is proportional to the difference in concentration on 2 sides of the membrane. So that is another use. So here's the equation that we talked about. So I wanted to do number 1 with you. Okay, great news. The pest population in Pestopolis is decreasing by 6% each year. So it's decreasing by 6%. So what is our multiplier if it's decreasing 6%? So hopefully you have a new sheet of paper. If I take 100, I minus 6. What is that, guys?
$94.
Thank you. 94%. Well, you have to change it to a rate. You can't leave it as a percent. So how do I change 94 to a rate? What rate would that be? 0.94, right? You move the decimal point over 2 places, or you divide by 100, and that will move the decimal place over for you. So that's your B value. That is your rate. So our B value, so our Y equals A times B to the X minus H plus K. So our B value is 0.94, right? So we have 0.94 to the X minus H plus K times A. We have to find A. We found B because they told us in the problem the rate. So that gives us our B value. So now we have to find our initial value, right? A is the initial value. The pest population, Pestopolis, was decreasing that much. 3 years ago, there were 60,000 pests. So since it's 3 years ago, that's going to affect the 3 is my H. But since it's 3 years in the past, I need to do 0.94 to the X minus -3 because it's 3 years before. If it was 3 years after, I just do X minus 3. Okay, if it was after, I would do X minus 3, but it's before, so X minus -3. So that becomes a plus. Okay. There were 3 years ago, there were 60,000 pests. So where am I going to put the 60,000? Am I going to put the 60,000 for the Y or for the A? We're going to put it for the Y, okay, because this is a specific value. This is -3, 60,000 is one of the points that they gave us, okay? So we plugged in -3 here and we plugged in 60,000 for Y. We've plugged in our X and Y. You're not going to plug it in for A, okay? Do not plug things in for A. In Math 1, we plug things in for A, but for this assignment, no, you plug it in for X and Y. So we're looking for A plus K, and since it says someday there will be no pests. So since there's not, like, let's say it says the number of pests will never go below 10,000, then we put plus 10 here. But since it's going to someday be 0, our K value is actually 0. Okay, so we don't really need that part, right? So this is our equation right here. Now we need to find A. So to find A, let's put in 0 into this, right? So 60,000 equals A times 0.94 to the 0 plus 3. I'm putting 0 plus 3 in here, which is just the third power, right? And there's a plus 0, but we don't really care about that. That doesn't do anything. So now I can solve this. Do we need to use any? We don't need to use any logs or anything, right? We just do this in our calculator. You put 0.94 to the third power in your calculator. And some of these, you're going to get long decimals that you want to store your answers for. So hopefully you remember how to use the answer button, the second negative button, to recall the last answer that you calculate. You don't need to do that right now, but let's just do this. 0.94 to the third power is about 0.830, and there's more numbers. So it's like 0.830A is equal to 60,000. Then we're going to divide by that 0.83 number. You want to use the whole number in your calculator, not this abbreviated form, because then your answer will be different. So let's do 60,000. So that's what I'm talking about. Type 60,000 divided by second negative, and it'll say answer. And that will mean the 8.830584 number. Okay, so press 60,000 divided by second negative, and it'll say 60,000 divided by answer, which is this guy right here. It'll basically do this. And you get 72,238. 72,238. It says 0.3, but you can't have 0.3 rats. So I would round to the nearest whole number. Okay, so that is our A value, right? So that's that number right there. So our equation now is 60,000 equals the 72,238 times 0.94 to the X plus 3. So how many are there now? Well, now would be when the time is equal to 0. Do we plug in 0 yet? I feel like we plugged in 0. So that's how many there are. Let's see, that was 3 years ago there were. So that's how many there are now, 72,238. Okay. At this rate, when will there be 30,000 pests? So we want to change this number to 30,000. Okay, we're we want to know when will there be 30,000 pests. So 30,000 equals 72,238 times 0.94 to the x plus 3. Okay, our x, notice our x is in the variable, so we're going to end up using a log at the end, not now. Do I multiply these guys? Do I multiply 72,000 times 0.94? Ever?
No, because there's an exponent and exponents come first.
Right. Order of operations is we're supposed to do this first. So you never, ever, ever multiply these two numbers, ever. What you do is you divide by this, by 72, by the number in front, you divide by that A value. So 30,000 divided by 72,238. And this is the work I should see on your paper, okay? This is the work that what's that photo math is not going to show. And this is the work I need to see on your paper to show me on a test that you actually did this problem. 30,000 divided by 72,238. So, and I'm going to use that the answer button again, or you can type in this number is pretty close. You could type it in. So I'm just going to do 30,000 divided by second negative, and it will give me. So when I did this, I got 0.415, and I'm abbreviating. There's more decimals, but I'm abbreviating that, equals 0.94 to the x plus 3. 0.94 to the x plus 3. Okay. Last time I told you to change it to log form. That's kind of, that's hard for some people. So let me show you an easier way, okay? You can just take the log of both sides, and your base is going to be whatever the base is that has the exponent, and this is your base. So let me show you what I mean. So this is something that we should have gone over last class period, but I think maybe we just did it very briefly, but I'm explicitly going over right now. So you do log of 0.94 of 0.94 to the x plus 3, and same base over here, log of 0.94, this is the base, of 0.415. Okay, so this is your base, this is your big number. So I'm going to take log base 0.94 of both sides, this side and that side. Why? Because I want to get rid of this log. And if you recall from our exponent property, can't we bring this log in front so that we get x plus 3 times log of this, log of base 0.94 of 94. Well, this is just 1, right? When you have the same thing like this, that's just a big fat 1, which is nice because that goes basically, essentially, this goes away because you have 1 times x plus 3. Okay, and so this is x plus 3 equals, now this log base 9, we need to use change of base formula to put this in our calculator. This is something that, what's it called? Photo math is not going to show you, but you're a human being and you're going to show me how to do this. And you're going to do log of 0.415 over log of 0.94. Okay, so we're going to do this in our calculator right now. When you do that in your calculator, you should get, what did I get when I stayed up for 2 hours last night working on this lesson? Let's see, where's number? Actually do prepare quite a bit for some of these lessons, especially at the end of the chapter when they get more difficult. What did I get? I got like 14.2, right? So this is 14.2, and then I'm going to minus 3 from both sides. Minus 3 equals x. So when you minus 14.2 minus 3, you get 11.2. So x is approximately 11.2. So when will there be 30,000 pests? 11.2 years later. The number will drop from 60,000 to half of that, to 30,000. Okay, so that's your answer for B. I just don't have room to put it right here, but I would put it right here. C, what is the half-life of the population? Well, the half-life is, when is it going to be in half? Well, half of 60 is 30. So we just found that, right? So 11.2 years later. That's nice. We don't have to do any more work. The half-life. Half-life means when is it, the number going to cut in half? Okay. 11.2 years later. Okay, I was going to do part of number 2 with you. Let me see if I need to do that. Oh, because this one has an asymptote. This one didn't have an asymptote because they went down to 0. I'm just going to ask you really quickly. What's the asymptote for this going to be? Let's read it. Haley has a car that will never be worth less than $3,000 because maybe it's a classic car, so it'll never be worth 0. It's worth $12,500 now and is depreciating at a rate of 10% per year relative to the asymptote. So what is the asymptote for this one, guys?
3,000.
It's 3,000 because it's never going to go below 3,000. So if we do a little sketch, which we should, okay, you should do little sketches drawing the asymptote in there. And PhotoMath's not going to do that for you. Another way I can tell when people actually pay attention and don't just use PhotoMath. Okay, there's a ton of ways. I'm telling you all my secrets, but I shouldn't. So 3,000, it's never going to go below 3,000. Right now, it is worth 12,500. So boom, 12,500. Is that your A value? Is this A? No. Okay, that is not your A value, even though it's the start value, because you have an asymptote. So your equation y equals A times B to the x minus h plus k. Which values do we know, guys? Where does the 12,500 go?
As the y.
Very good, as the y. So 12,500 equals, let's find the A value. We don't know. We always have to find the A value. We don't know the rate. Actually, we do know the rate. What is the rate if it's depreciating 10% every year?
0.1.
Not exactly. Because if you multiply, if I put times 0.1, it's only going to retain 10% of its value, and it's losing how much? It's losing 90% of its value if you put 0.1. So this would be super low. So it is 0.9. How did you get 0.9? 100 minus 10. Remember, I told you have to subtract. When you do depreciation, you have to subtract the percent from 100 to get your percent. Okay, you can't just use this. Even though 10% is 0.1, you have to subtract the 10 from the 100 to get your 90. So it's 0.9 to the x. There is no h. There's no shifting because it starts out at 12,500. So there's no h you have to worry about. But we do have to add a k. Your k value is 3,000. Okay. So I totally did most of this problem with you. So if you've written it down, you have it there. 2 people left, so they don't have it, but the rest of you are here. You need to go in and answer these 2 questions. Then you're going to try number 3 on your own. You're going to try number 4 on your own, anti-M. You're not going to do number 5 because I said to skip that one. There's actually a number 5 and you don't have to do that one. I tried it. It's kind of difficult. If you want to try it, you can, but it's a pretty difficult problem. So I'm not assigning number 5. I just want you to do 1 through 4. We did basically 1 and half of 2 together. So you need to finish up number 2, 3, and 4. I made this a homework assignment since we, you know, you're not going to finish it today. So it's not due till Monday. Now, since the test is next week, I had to put a review assignment. And since the practice test is on our next class period, Tuesday, this is what I've done. Okay, so that assignment is this guy right here, right? So I had to assign another assignment. Don't flip out on me yet. This assignment is not due Tuesday. This review assignment is due Wednesday, okay? Our async day. This is due on our async day at 3 o'clock. And then I'm going to release the answers after 3 o'clock. If you turn in your assignment after 3 o'clock, points will be deducted because I'm putting the answers out there after 3. Okay, so if you want to get full credit for this review assignment, and you only have to do the odds, I only assigned the odds. There's 35 problems, so that brings it down to 14 problems for you instead of 35. You're welcome. You only have to do the odds, and then I will release the answers on Wednesday since the test is on Friday. So that gives you between Wednesday and Friday to check your homework, to check this review answers. Okay, So I gave this assignment ahead of time, so it gives you longer. If you want to do it this weekend, awesome. If you want to wait till Monday or Tuesday or Wednesday to do it, great. That's up to you. You can pace yourself. Everybody has different schedules. Some of you have football practice, volleyball practice, some of you work. So just do this between now and Wednesday, 3 p.m., whenever you have time. I would wait till Monday, Tuesday, or Wednesday to do it because you want to do it closer to the test. If you do it all this weekend, unless you're really busy Monday, Tuesday, Wednesday, then do it over the weekend. But if you do it all over the weekend, you're going to forget a lot of it Monday, Tuesday, Wednesday. So you at least want to study it after you do it, like Thursday or Friday. Probably study it Thursday for the test. Does that make sense, guys? Okay. All right. So make sure to turn in your classwork here. All the notes that we've taken today, we took a lot. You want to turn it in, 12 people have turned it in. Awesome. And then finish up the homework assignment. Hopefully you can finish that. We actually have 20 minutes left, so you can finish up that homework assignment there. And then the review is there. And then I will see you on Tuesday, next class period.
I have a quick question about the